Hello everybody, Miss Winfield here, ready for today's maths. So let's have a rewind, okay, and let's practice using that method of crossing through 10. And you are going to be so sick of this by the end of the week, but you are going to be so good at it, okay? And that's the reason why we've put in a little bit more support around this, because it is a tricky concept and we understand that you might find it a little bit difficult, okay? So that's why we've done a bit extra this time. So let's rewind our learning, okay? And we've got a problem here that we need to solve. But before we're going to solve it, I'm just going to remind myself of our 3 steps to success. So step 1, we need to partition the part into subparts, okay? Step 2, we're going to subtract the first part from the whole. And step 3, we are going to subtract the other subpart. So let's have a look at our problem. There are 14 bees in a hive, okay? Let me just share my screen with you so you can see my working out as well. Okay, so you should be able to see my screen now. Sorry about that. So there are 14 bees in a hive. 6 of them fly away. So we are subtracting 6 of them because 6 of them have flew away. How many bees are left in the hive? Okay, so let's look at step 1. We're going to break down, we're going to partition our part into 2 subparts. And here I've got 6 ones. Okay, let me just show you that. There we go. And within the number 14, I've got 1 10 and 4 ones. Now, 4 is less than 6, and 6 is actually made up of 4 and some more. So 4, 5, 6. Oh, yeah, it's 2 because I had to say 4, 5, 6. I had to add 2 more. So I've done step 1, okay? And now I can do step 2, which is to subtract the first subpart from the whole. So I've got 14 and I'm going to subtract the first subpart, okay? And I know that if I were to take away 4 ones, I would just be left with a 10. So I've been able to cross through 10. So if we look on this side, it's exactly the same. I've taken away 4 to get me to 10. And now I can do step 2, which is to step 3, which is to subtract the other subpart, okay? So I'm going to start with 10 because that's where I've got to at the moment. Once I've taken away my first subpart, take away the 2, and I know that that is 8 because I know my number bonds to 10, and I know that 8 add 2 is 10. So if I was to take away 2 from 10, okay, take away 2, I would be left with 8. So 10, I took away the 2, which left me with 8. 14 take away 6 is therefore 8. So there are 8 bees left in the hive. Let's have a look at this one. Now, this question, okay, it's not a little bit more tricky because it's this, we can work it out the same way, but we're being asked to choose who is right. So Meg has got 12 bags of crisps. Okay, Meg has got 12 bags of crisps. She gives 7 away. How nice of her. She gives 7 bags away. How many does she have left? Now, Tom is saying that she will have 5 left. Maya is saying she will have 6. Sam is saying she will have 19. Okay, and Lily is saying that she will still have 12. What do we think? Maybe we could work it out and then see who is correct. But I know instantly that Sam is definitely not correct. Sam has got this one wrong because he's saying 19. Well, we only started with 12, and if she's given some away, then the number is definitely going to be less than 12 because she hasn't gained more. If Meg had been given 7 extra bags of crisps, then Sam would be right, okay, because she would have 19 altogether, but she hasn't. Remember, we're subtracting, we are not adding at the moment. So, same again. Let's work it out, okay? Let's partition our part into subparts. got the number 7, which is made up of 7 ones, and the number 12 is made up of 1 10 and 2 ones. Okay, I know that the number 7 is also made up of 2 ones and some more. So let's start at the number 2 and let's stop when we get to 7 and see how many more fingers we had to add. So 2, 3, 4, 5, 6, 7. I had to add 5 more because 2 and 5 make 7. So I've done step 1, okay, and now I can subtract my first subpart from my whole. And if I were to take the 2 ones away from this number, I would just be left with a 10. So I know that's 10, so I've been able to cross through 10, okay, and then I can take away the remaining subpart. Then take away 5, I've got 10. I take away 5, I'm still left with 5. So, which of the children said 5? Was it Tom? Was it Maya? Was it Sam? Was it Lily? Who was correct? Well done if you said Tom was correct. Tom told us that there were 5. She was left with 5 bags of crisps. So that is our rewind, okay, and today we are going to do something a little bit different. We're going to wear our evaluated glasses. Can you pop them on? There we go. And we're going to evaluate subtraction problems. And we can do this by retrieving old learning so that we can work out and explain who reached the correct answer most efficiently. So we're also going to be wearing our Explain It glasses today. I have lots of pairs of glasses on. So let's just have a look at this problem. James and Alyssa are both trying to solve 12 subtract 6. We can see it here, look. James says, I've used a 10th frame and the answer is 7. Alyssa is saying, I've used a number line and my answer is 6. And I can see straight away that Alyssa has used the method that we've been using, which is to cross through 10. Because she's got to 10, okay, she's got to the services, she's got herself a cup of tea, and then she's taken away the remaining part. So, before I can make a judgment of who has got this correct, what do I need to do? What do you think? I need to work it out myself, okay? So I'm not going to say, oh, wow, Alyssa is a girl and I'm a girl and I think all girls are correct, so Alyssa's definitely got it right. That's not true, by the way. I don't think that at all. But I can't just decide. I can't say, oh, well, actually, I think I like James's hair, so he must be correct. I've got to work it out, haven't I? So my problem is 12 subtract 6. Okay, and it's written down here, just like we have been writing it on the board. Well, let's do step 1. Let's partition that part into subparts. So, the number 6. Well, the number 12 is made up of 1 10 and 2 ones. And I know that there are 2 ones in the number 6. There are 2 ones and some more. Okay, there are 2 ones, and I know that there are 4 more because 2 add 4 makes 6. And now I can do step 2. I can start at my whole because when we subtract, we start with the whole, and I can subtract my first subpart. So I'm going to take away 2. 1, 2, and I've landed on the number 10, which has been enabled me to cross through 10. So I've taken away the 2, and now I can take away the remaining subpart, which is 4. So I'm going to start at 10, okay, because that's where I've got to, and I'm going to take away 4. Here we go. 1, 2, 3, 4. So here I took away the 2, the first subpart, and here I continue to take away the 4, which is the second subpart, and my answer is 6. So James was saying that his answer is 7, and Alyssa was saying her answer was 6. So who got the question right? Well done if you're saying Alyssa got it right, and you can see she's worked it out the same way as me. Let's have a look, though, at what James did and where he might have gone wrong. Because I can see that James has drawn 12 red dots. Perfect. His whole is 12, and he's drawn 12 red dots on his 10 frame. And then what James should have done, okay, he should have crossed out 6 of them. Let's check. 1, 2, 3, 4, 5. Oh dear, I think that's where James has gone wrong. Because if James had crossed out the last one, then he would have also been left with the answer of 6. So that just shows why it's better to always try and cross through 10, okay, if that's the most efficient method, because James has made a mistake here, hasn't he? And he's undercounted. So that's where James went wrong. Let's look at the next example. Lola and Jake are both trying to solve 16 subtract 9. Okay, so 16 subtract 9. Let me write that on my whiteboard so we can do it together. There we go. So I've got my part and I'm going to partition that into 6 and some more, because the number 16 is made up of 1 10 and 6 ones, and the number 9 is made up of 9 ones. So there are definitely 6 ones in the number 9, but there are 6 ones and some more ones, okay? And I know that 6 and 3 more equals 9. And now I can do the easier bits, which is to take away the first subpart. Well, I've got 1 10 and 6 ones, okay? If I were to take away those 6 ones, I would just be left with 10. So I've done step 2, and step 3, I can take away the remaining subpart, which would leave me with 7, because I know that 3 and 7 equals 10. So my answer is 7. Oh, okay though, but Lola says I got the answer 7. And Jake says I got the answer 7. So who's right? Or are they both right this time? Well done if you said they're both right, but that is not our question. Our question isn't who got the answer correct. Our question is who solved the problem most efficiently? And how do you know? Have a little think. Do you think Lola solved it the most efficiently using the crossing through 10 method? Or do you think Jake solved the problem more efficiently using the counting back method? What do you think? So hopefully you're saying that you think Lola worked it out more efficiently, okay? Because Lola started at her hole, she got to 10, she crossed through 10, and then she continued to take away the other part. We've just seen on the last question that James made a bit of a mistake, okay, because he undercounted. Now, Jake hasn't done that. He's managed to get it right, but that is a bit of a risk when you're taking away a larger number that you could undercount, okay? So efficiently, who's worked it out in the best way? I would say that Lola worked it out in the best way. If you agree with me, put your finger on your nose. Super stuff. So now it is going to be your turn, and I know that so many of our children are going to love this activity because for some reason, when we get the timers out and we put the pressure on, you love it. So what I thought you could do, I'm going to put this sheet on the class story. Please don't worry if you've not got a printer, okay? You can just write the problems down. It's not a problem at all. So these are called Mad Maths minutes, and you are going to have a certain number of minutes to see how many of these problems you can solve using the crossing through 10 method. So you might want one sheet with either the problems printed off, or like I say, you might have a sheet that your grown-ups could write for you, or you could write just with the problems, and then you might want your whiteboard or some plain paper for you to work out your answers using this method. So what you're going to do, you are going to set a timer, whether it be on your watch, on your phone, on your iPad, okay? You might ask one of your grown-ups to count to 120 if you wanted to do 2 minutes. Okay, only joking, grown-ups, I don't expect you to sit and do that. You might want to even use a timer on the oven. There are lots of ways you could time yourself. So you're going to set yourself 2 minutes and see how many of these problems you can solve. Okay, and you might want to do 2 minutes and look at this side, set A, and then you might want to do another 2 minutes and have a go at set B. Now, if you want a little bit longer, you could do 3 minutes, you could do 5 minutes. You might want to start at, say, 10 minutes and then decrease the time a little bit. It's completely up to you. But let's see if you can complete these mad maths minutes, okay? And see if you can complete as many of these as you can. So I wonder if you can try and complete all of them. Okay, only joking. You can do as many as you want to do, and keep practicing, because you'll be practicing and consolidating those skills that we've been learning for the last couple of weeks. So have a go, see what you think. Like I say, if you need more time or less time, I'm going to leave that one up to you. Okay, so get those timers out and get cracking with your mad maths minutes. See you all soon.